All right, this lesson is on geometric sequences and series. So very similar to arithmetic, except instead of having a common difference, we have a common ratio. So if you were to divide two consecutive terms by each other, it should equal the same thing. For example, if we took the sequence 2, 4, 8, 16, all the way down, this is again 2 to the nth power would be the sequence. This is geometric because 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So we call this, when they divide by the same number, we call this the common ratio. So for geometric sequences and series, this is the common ratio. Another example, so if we took the sequence 4 times 3 to the nth power, you might have 12, 36, 108, 324. Again, it goes on forever, but if you look, 36 divided by 12 equals 3. 108 divided by 36 equals 3. It's going to equal 3. Just another example, you can also have like numbers that are decreasing, so maybe negative 1/3 to the nth power. So our sequence, again, when it's negative, it's going to alternate between positive and negative. So those are just a few examples of a geometric sequence. We use this is our base formula for a sequence. We take our first term, and then we take our common ratio, n minus 1. So this is like our base form of geometric sequences. So like we could write a sub 1 times r, a sub 1 times r squared, a sub 1 times r to the third, all the way until we get a sub 1 r to the n minus 1 term. Finding the terms of a geometric sequence. So say you had to write the first 5 terms of a geometric sequence whose first term is a sub 1 equals 3, and the common ratio equals 2. A sub 1 equals 3. 2 times 1, 6. A sub 3 would be 3. 2 to the squared would be 12. (24), and a sub 5 would be 3. 2 to the 4th power, which would be 48. So you can write, you can find specific terms of a geometric sequence again. Whereas arithmetic was multiplying or adding and subtracting, geometric is going to be multiplying and dividing by the same number. Find the 15th term of a geometric sequence whose first term is 20 and whose common ratio is 1.05. So a sub 1 equals 20. Common ratio is 1.05. So again, if I use my base formula right here, I would say to find any term, a sub n equals my first term, which is 20, times my ratio, which is 1.05 to the n minus 1 term. So in this case, if I was looking for the 15th term, I would do 20, 1.05, 15 minus 1. So my 15th term is 1.05 to the 14th power, which is approximately 39.599. Find a formula for the nth term of the following geometric sequence. What is the 9th term of the sequence? So say that we are just given a sequence. We're not given the formula. We need to find what the common ratio is. So again, how do I find the common ratio? I take my two consecutive terms. I'm just going to do one more to double check. Yep. Okay. So my common ratio is 3. Therefore, I can figure out that my first term is 5. So I can write the formula as 5, common ratio 3 to the n minus 1 term. So if I was looking for the 9th term, I would say 5, 3, 9 minus 1 is 8, which again is going to give me 32,805. So what you'll notice in geometric sequences is that they get bigger and smaller much faster than an arithmetic sequence. Okay, finding a term of a geometric sequence. So let's say that the 4th term of a geometric sequence is 125. The 10th term is 125 over 64. Find the 14th term. Assume that the terms of the sequence are positive. So the 10th term of the sequence is related to the 4th term by the equation. So if I'm looking for the 10th term, I would say, all right, well, that's like taking my 4th term and multiplying it by my common ratio to the 6th power. Again, looking at here, 4 plus 6 gives me 10. So I would say, all right, we'll plug in what I know. I know that this is 125 over 64 equals, my 4th term was 125. I don't know what my r is yet, so I'm just going to keep it like that. If I do divide by 125, I'm left with 1 over 64 equals r to the 6th power, which when we find out, what number raised to the 6th power is going to give me 1 over 64? That means that 1/2 equals r. So if you did 2 to the 6th power, you'd get 64, but because it's 1 over 64, that's why we have to say that our ratio is 1 over 2. So to find the 14th term, I would take this number. I would say, all right, I want my 10th term. R to the 4th power, again, 10 plus 4 gives me my 14th term. 125 over 64 times 1/2 to the 4th power. It's going to equal 125 over 1024.